Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to set up our very own collision manager. Now, while there are collision managing plugins for EaselJS, for many games, they're going to be overkill, and they'll be much more difficult for us to fine-tune the performance of them as well. For a game like this, we only need very simple collisions. All we really need to know is if two things get too close to each other. We don't need to be working out complex shapes or calculating physics interactions either. If we build something ourselves, we'll be able to fine-tune it and make sure it runs as fast as possible. So let's get started. Open up your project and run grunt. And then before we start, I just wanted to show you a couple of things I've added to our project. I didn't want to waste time setting up a bunch of things, but obviously we'll need to have some obstacles to test our collisions. So I've set up a Meteor class with this Meteor PNG. If we open up the source code, you'll see I've created a Meteor class here in the lib, and it's really very straightforward. Its subclass is container, it sets its X and Y, gives itself a name, and sets its body as the Meteor PNG. And that's it. Then, in the main file, I included that class and instantiated 4 meteors near our hero. So if we see our project here, you can see the meteors, and you can see that we currently don't interact with them in any way. We can just fly straight through them. So let's make a collisions module to manage that. So right-click on your lib folder and create a new file. We'll save this as collisions.js. We will need the easel event class, and we will need an array of actors. An actor is a name I've given to anything that interacts with anything else in our game. Our collision service is going to need to have the following capabilities. On module exports, we're going to be exporting an add actor function, a remove actor function, and a function to broadcast all the collisions. This is the function where most of the calculations will be taking place, and we'll be calling this inside of our main tick function. But firstly, we need to be able to add and remove actors from our list of colliders. So when we add an actor to the actors array, we're going to need to be passed in the object to be added. This is the actor itself. So our hero or a meteor instance, for example. The type of collision. I plan on having 2 different types of collider for this game. Circle colliders, which have a certain area, a circle around them that kind of defines the collidable area of our actor. And then options contains any other information that we may need. So firstly, I need to see if the actor already exists in our actors array. So I do actors.index of object. If index does not equal -1, that means that the object is in the actors array, and we should console log a warning. Otherwise, we're going to set some collision info on the object itself. So that we could keep the actors array clean and just include the actors themselves, I've had to include the collision information directly on the actor itself. I have to remember to remove this property when the actors are removed. So this can have a type and options set up. Then we will push our object into actors. Next, to remove an actor, we do much the same thing. We check if the actor is there. This time, if it isn't there, we log a warning because we're trying to remove something that isn't there. Then we delete the collision info property from our actor, and we can splice the actor from the array and return the result. Okay, so it's time to do the actual legwork of this module, which is going through our array of actors, comparing it with every other actor in the array, and seeing if we have any interactions. So we're going to have a broadcast collisions function. We will keep an array of the collisions that we build up, and now we need to iterate each of our actors, and we'll need to do that twice. So the first time I'm going to call it the object self, and then we're going to iterate again so that we can compare each actor to every other actor, and we'll call it other when we do it the second time round. First, we'll need to get the object info from each of the actors. So we've got self info and other info. Next, we obviously need to make sure that self is not equal to other. We don't want to compare objects to themselves. Now we can check the type of collision. So if self_info.type equals circle and other info.type equals circle, then we have a collision between 2 circle colliders. In this lesson, that's all I'm going to deal with. Next lesson, we'll create point colliders which we'll use to create lasers for our hero. But for now, if we have two circles and we want to know if they are colliding, all we really need to do is see if their distance from each other is less than the total combined radiuses of the two circles. So we're going to get variable distance equals self_info.options.radius. So options is where we'll keep this information, and add that to other info, and that is our collidable distance. Then, if that distance is greater than the distance between our two objects, then we have a collision. I'm going to create a helper function called distance between that will accept two objects, self and other. In this case, we're going to create a new collision event. That's going to equal new easel event collision, and we'll set the collision event .data equal to self being self and other being other, and then we can add that to our collisions array, and we'll also need to add the target. So the target in this case is self. A similar event will also be fired when the same process happens on the other, when other is self, and our event is collision event. Now the reason we're putting these all into an array first is because if we start broadcasting events onto these objects right now, we could run into problems because the objects may start acting on those collision events before we finished iterating the array, and maybe some of the objects that we're iterating will be destroyed before we get to broadcast to them. So after we've finished going through all of our actors, we can iterate the collisions array and get the target and dispatch an event on the target. The event is obviously info.event. Now all that's left is to create our distance between function. Distance between, and we have two objects passed as arguments. Then to get the distance between 2 points, we need to do math.square root of the square of the distance between the x positions and y positions. So do math.pow object1.x minus object2.x, and then to the power of 2, and then add math.pow object1.y minus object2.y to the power of 2 as well. To see if we've got this right, we'll first need to add our collision service to our main module by requiring collisions. Then on each update, before we actually update the stage, we'll need to call collision service.broadcast collisions. Then anybody who's listening out for collisions will receive them as events. So in one of our actors, we'll need to register this object as an actor, so we can get the collision service and then call collision service.addActor, passing this as the object, circle as the type of collider, and for options we'll pass in a radius of 48 because our meteor is more or less a circle with a radius of about 48. We can go to our hero and do the same. We'll register the hero, collision service there, and we'll add this hero to the collision service with a radius of 40, more or less to these values here. And now our meteor can listen out for collision events. So if our meteor happens to have a collision with another object, we're going to want to first find out what that other object is. We can get other from the event data. Then if other.name equals hero, we'll want to be destroyed because the hero crashing into us should destroy the meteor. It's obviously going to do some damage to the hero as well, but that's for the hero to decide. So we'll get the collision service and remove this actor, like so, and then to remove the meteor from the stage or from the world, we'll call this.parent.removeChild and pass in this. And before I continue, I'm sure some of you have already noticed this should be not equal to in the broadcast collisions function. So now if I head towards one of these meteors, you'll see that as soon as the ship touches the meteor, it disappears. On the other side of that, we have our hero, which should also be listening for collisions, and our hero, if the other object is meteor, should take some damage. We can now make a method for our hero called takeDamage and allow it to take an argument, in this case 20. In our prepare properties, we can set up our hero with some health and start him off with 100, let's say, and then give the hero a take damage method like this. The take damage method will take an argument, the amount of damage, and then when our hero takes damage, he will first have his alpha set to 0.5. Now I'm sure you can come up with many more nice animations to signify that the hero has taken damage, but in the classic style of computer games, our hero can become semi-transparent when he takes damage to indicate that he won't be able to take damage again for a certain amount of time. We can then set our health to health minus the damage. We'll console log what our health is currently at, and then we can create a set timeout to restore the alpha back to 1 after 2 seconds. So now when we crash into a meteor, you see the hero go semi-transparent. His health is now at 80, 60, 40, and 20. Well, that's all for this lesson. Check back in for the next lesson where we'll be creating a point type of collision and using it to allow our hero to fire lasers that destroy the meteors. Ciao!